good evening. Well, good day, good morning, good afternoon, wherever you are in the world again. It's evening right here. And welcome to another stream for Freaky Physics. Today we have a lesson with Ariana, so we're gonna do a math lesson today. So let's change the title. Let's change the title later when she's actually here. Okay, hold on. I'm trying to open my space desk. It's weird. Hold on. So this. Huh. Hmm. Okay, since I can't do that, I'll just go in first and see what happens. Okay, so let's get into it. Hi, Ariana. Good morning.
Hello.
How are you today, Ariana?
I'm good. How are you?
I'm doing fine, thanks. All right. What are we doing today?
Um, well, it's wait. Oh, I forgot what it was called. It was like
Mm-hmm.
it's like hold on. Wait, actually, do you mind if I get it real quick?
Sure, no problem.
Yeah, thank you. Hold on. Wait.
There we go.
It's like a unit circle, and
Oh,
like with
okay.
like the pi over 2 and like pi over 6, pi over
I
4.
get it. All right.
Yeah.
All right.
Mhm.
Okay, let me just. Can you send over something so at least I can, you know, look at it and see exactly what you're looking at. But I have an idea already what it is.
Okay. Yeah. I have like a thing that we filled out, but
Mm-hmm.
I'll send you that.
Sure. Okay. Um.
Are we gonna use the
Mm-hmm.
new board, or are we doing another board?
We'll use the same board as before.
All right.
Okay. Um. I'm just opening it right now. Here we go. Okay. Let me get to our board, Ariana. Yeah, we are. Why? Say hello.
Hi. I'm saying hi.
Hello.
Let me turn on my camera and wave.
All right. Say hi. Okay, I got it. Blank unit circle. Okay, got that. All right. So let me just open that real quick and then we can start. Okay.
Mhm.
Okay. Um Again, let me get that on the screen as well. Okay. So
Mhm.
anyway, looking at this, basically what is this? It's just basic okay, let's take a look at what the unit circle actually is first. Okay? So the unit
Mhm.
circle, how do you understand that? What the unit circle is?
Um, I kind of understand it as like the like each part of the circle is like some sort of like angled triangle.
Mm-hmm.
You just kind of have to add the line.
Right. Okay.
Mhm.
One thing about it, why do you think it's called a unit circle?
Because it has circles. It's a circle telling you units.
Not quite. It's called a unit
Oh.
circle. It's called a unit circle because remember what we said last time, that the trigonometric functions are basically just ratios? Did we do that?
Yeah.
Okay. So,
Well, I think.
okay, they're the ratios of sides, right? So the
Mhm.
now basically, if it's just a ratio, then it's gonna be a really good idea to just have some sort of measurement wherein one of the sides is always one. Okay.
Mhm.
Now that's exactly what the unit circle is. Okay. The unit circle is a circle with a radius of 1.
Ah. Okay.
That's what it is. Okay. Now the reason why it's really useful, the reason why it's really useful in trigonometry is because if the r is equal to 1, then that means if you have any, oops, I'm gonna get out of that. Okay,
sorry. Sorry.
that's
No, I was
fine.
just. I
That's
was just
fine.
trying.
Okay, so if we're gonna assume that the x-axis and the y-axis are like that again, so this is the x and the y-axis, and then you draw the unit circle with its center at the origin. Okay,
Mhm.
mm, origin. The idea is no matter what you do, this will always be 1. In other words, the hypotenuse of any right triangle you inscribe within the circle, the hypotenuse is the radius of the circle, right?
Mhm.
Okay. So that's why it's very useful, because later on, as you have here on this worksheet that you just shared with me here,
Yep.
okay. Um, basically, I'm just gonna put that in here. Um, hold on. Why is it like that? There. Okay. So basically, for the unit circle, all you have to really do now is just fill in a few things about it, know what something about it is, and then the rest kind of follows. Okay. This
All
is what
right.
I mean. Um, okay. So let's fill this in. Uh, okay. The reason I want to go through this filling in stuff is because it's gonna make it a lot easier for you to remember these, because you're expected to remember these particular angles. Okay.
Yeah.
All right. Now, to make this easier, we're not going to fill in the full unit circle just yet.
Okay.
Okay. So we're going to focus on this bit by bit. So we're going to start with this, well, sort of a triangle, right?
Mhm.
It's sort of a triangle, but it's not really one, right?
Yeah.
Because that's, what's
So
this basically? What's the x-axis? What's the x coordinate of this point right here?
0, 1.
That's 1. X coordinate is 1, right?
Oh. Yeah. Yeah.
What's the
I was just like
yeah, what's the y coordinate of this? The y coordinate
0. Oh,
0.
that's.
Yeah,
I,
go ahead, just write that there.
I forgot to remove the
Okay.
line.
Now, the reason why we're starting off with that is because basically the idea here is, oops, did you move that or did I?
Thank
All
you.
right. Okay. So you get the idea on these lines on both the x and the y axes. These ones are pretty straightforward. Their coordinates are pretty straightforward, right?
Mhm.
So how about here on this one? What are the coordinates there?
Um. Since the y is this is why it would be one. Wait, no, not that's not the one.
Mm-hmm.
1, 0.
1, 0. All right, correct. Okay, and then let's go to the next one right here.
Um. This is kind of gonna be like a little graph. So would it be like the negative
Yeah, it is. It is -1.
one? Okay.
Simple enough, right? And then the last one,
Mhm.
the last
Guessing it's
one is
just
what?
gonna yeah
Mm-hmm.
0, -1.
0 and -1. Okay. Now, for now, we're gonna ignore these guys here, here, and here. We're gonna ignore them for
Okay.
now. we're gonna focus our attention on the first quadrant.
All
Okay?
right.
All right, so I'll just undo those real quick. Okay, now I want you to, without, even if you don't actually measure it, look at this. I'm gonna change color for now. I'm gonna use blue for this, okay? So for this,
Mhm.
I'm gonna draw a triangle like this, right?
Mhm.
Okay, and there we go. And I'm gonna extend it all the way here as well. Okay.
Mhm.
Now, we know that is uh this is one of those special angles. Okay. One of the special
Yeah.
angles in the unit circle is the 30-degree angle.
Mhm.
Okay. Now, uh, okay, I'm gonna ask you something real quick. What does this
All
more or
right.
less look like to you? The y coordinate right here. What does that more or less look
That
like? What value is it? If the whole thing is 1, if this whole thing is 1, what value is this? Just by view, just by inspection.
half.
It's 1/2, right? More, it
Yeah.
looks like 1/2. In fact, this
Mhm.
is correct. This is 1/2.
Oh.
Okay. All right.
Mhm.
Now, here's the thing. You do have, in other words, this length here is 1/2, right?
Mhm.
And the hypotenuse is 1.
Mhm.
Okay. So let's take a look at this now. We don't really know what this is exactly, but that more or less is around um what do you think that is more or less? This x coordinate right here. More or less.
Um,
Just by looking at it.
1/4 or like a fourth of
Okay.
something.
I wouldn't say 1/4 because 1/4 would be here, right?
Oh, okay. So like 3/4.
Around 3/4 is a good enough estimate, right? Here's the
Mhm.
thing I want you to try though. Let's do some trigonometry right here. Trigonometry,
Mhm.
okay? So remember Sokatoa?
Mhm.
Katoa. Which one is gonna be the most useful to find the x-axis? Use what to find
Uh,
x-axis? Or
sine.
we can use sine? Sine, not quite.
Oh.
Or better yet,
Um.
okay, never mind. Let's just do that to find x length, right?
Mhm.
Okay. So what's x here? X is equal to um sorry, let's do it the other way around. It's actually cosine. Cosine of
Oh, okay.
30 degrees, okay? Cosine
Mhm.
of 30 degrees is equal to um adjacent is we don't know, so that's x over 1, right?
Mhm.
Which simply gives us x. So cosine 30 degrees, right?
Mhm.
So I'm gonna say out on a limb now that the x coordinate right here is the cosine of um 30 degrees. Whoops, that was me.
Oh, that's. I'm like looking at your side. I was like, oh, that's a lot of.
That's that's the x coordinate, right?
Mhm.
Okay. So this kind of tells us also that the y coordinate is equal to sine of 30 degrees. This is why we say sine of 30 degrees is 1/2.
Mhm.
Okay. Now, one thing we will do now is, yeah, Sokotoa doesn't really tell us much because you can just calculate that from a calculator and it will tell you something, right? Do that on a calculator real quick though. What's cosine 30 degrees?
Um.
If you put that in a calculator.
0.866.
Okay, 0.866. Not really useful because that's not an easy number to remember, right?
Yeah.
Dot, dot, dot,
Mhm.
right? Now, we'll
Mhm.
do something else. We will do something that you should have learned. I don't know if you've learned this yet, but
I
basically,
have, but I'm just having a hard time remembering it.
yeah. So that's why we're gonna go through it like this because if you think about this, this is also a right triangle, right? And you can think of
Mhm.
it as c squared. If this is a and b and c. How do you find a? A would be
Uh,
equal to, well, let's start.
like C.
We start with this,
Yeah,
right?
C2 equals A2 plus B2.
B squared.
Or
B
well, squared. Squared.
Yes, yes,
Yeah.
exactly. But we know C, that's 1, right?
Mhm.
We know our B, our A we still don't know, but we know our B, that's 1/2, right?
Mhm.
Squared. Now what, so from here, what can we get? A squared is equal to 1 minus 1/4, right?
Mhm.
And that's gonna be 3/4. That's A squared. Now it kind of makes sense. From here, what
Ooh.
can we get now? So A is equal to square root of 3 over 4, right?
Mhm.
Let's zoom out a bit so you can see that. So we can now say confidently that this number, cosine 30 degrees, is square root of 3 over 4. And that is what we will put here. Square root of 3 over 4. Okay?
Okay.
All right.
Mhm.
Okay. Uh, okay. That makes it a bit easier to see now, because basically what are your numbers here? You're either 1 or 0, or square root of 3 over 2, rather. Square root of 3 over 2, not over 4.
Uh.
Right? Because you took the square root of
Mhm.
4, right? So,
Yeah.
okay. Now, I want you to now realize something. And this is where it becomes a lot easier to memorize than just trying to memorize the whole thing.
Mhm.
Okay, I'm gonna make you look at the second, at this triangle right here. Does that look kind
Mhm.
of familiar to you?
It looks similar to that one.
So it's just the other one, but kind of flipped over, right?
Yeah.
So what do you think the numbers here are? The coordinates are for that next angle. Okay, one more thing
The
before we go there.
same.
Before we go, we know, if you said that they're the same, then this is the 30 degrees here, right?
Mhm.
Okay, but which one is 1/2 now? Is it the x or the y coordinate?
Um. Is it gonna be the X? Yeah.
Which one's x? The 1/2, right?
Yeah.
Correct. So that's 1/2. And therefore, since it's similar to the other one, this is going to be square root of 3 over 4. Square root of 3
Mhm.
over 2, right?
Mhm.
Okay, we're getting somewhere. And one last thing,
Hmm.
I'm gonna erase this angle here, this 30-degree angle. Oops, sorry.
Oh, you just erased everything.
I just erased everything. I'll just undo and erase that 30-degree label. Okay, this is again the 1/2 now, and the square root of 3 over 2 here, right?
Mhm.
Okay, and now, what's that? We're not gonna measure the 30 degrees there, we're gonna measure the 60 degrees thing. It's still gonna give you the same answers for the coordinates, right?
Mhm.
Okay, so, all right. Now, let's go to the second, third, and fourth quadrants. With knowing these two, what are these things right there? You can fill those in just by already kind of reflecting all the things we've done onto the x and the y axis, right?
So it's kind of just the same thing, but because of but it's like kind of like what's called a graph. So it would
Mm-hmm.
just either one would be negative.
That's right. So there should be a negative on one or both of those values, right? Okay,
Hmm.
so, okay,
I'm gonna.
Go ahead. That's correct. Mm-hmm.
Oh, but
Okay, great. There we go.
gonna
Mm-hmm.
maybe I'm gonna.
Well, okay. Just finish that up, and then let's go to the last one. I'm going to use green on that one once you're done.
Okay,
Okay.
I think
I
both
hope
would
it.
be negative. I
I
think
hope
in
this
this.
all makes sense now. I hope, because
It does. It does now. I'm just like, huh?
okay. The only thing you really need to memorize at this point is the
Uh,
30 and 60 degrees, right? The rest
okay.
follow. Okay.
Mhm.
The rest follow simply because you're looking at a graph of the circle.
Okay. I'm like thinking,
Mm-hmm.
trying to think of this like yeah, like a graph, like the axis, like the positive negatives.
Mm-hmm. Mm-hmm. Exactly. In fact, the way you said it, that's how it's supposed to be looked at. You're supposed to look at the
Really?
graph. Yeah, you're supposed to look at this graph and say what the coordinates are based on what we just found out on the first quadrant.
Okay.
Okay, great. So these are the values. Now, let's of course add those angles now. So that's 30, 60, and this would be, I'm just gonna write the angle, the angle value right here. So this
Mm-hmm.
is gonna be, well, this one is 60 degrees going that way, right?
Mm-hmm.
So that would be 120 degrees, right?
Mm-hmm.
Okay, why does it keep doing that? That's weird.
I don't know.
Okay,
Is there a
anyway.
way to like make it so that it's like locked in?
Mm-hmm. That's 120 degrees, right? And then
Mm-hmm.
this angle here is what? That's 30 degrees here, right? So of
Mm-hmm.
course that would be how much? What angle would that be from here? So basically this angle here is what?
Mm,
150.
okay. I was just trying to do the math in my head. I was just like, okay, what,
Okay.
180 minus 30.
All right. So let's do the rest of these. Just write the angles for here, here,
Mm-hmm.
here, and here. Write those angles. So I'll just write here 30 and
Okay.
60 here.
No, 30 plus 180.
Okay. After that, I think it's best if I do another one rather than write on this thing again. So,
Alright. 360, 330, and
mm-hmm.
300, I think? Yeah, maybe.
Yeah, that's 300 and then the last one is 330. Yep, correct. All correct.
Okay, yay!
All right. There is another way to do it though.
Hmm.
This can be negative 30. This can be negative 60, right?
Mm-hmm.
And then this is negative 120 and then this is negative 150. all of
Ooh.
these are all of these are still valid, so you just have to be a bit careful when you're given problems. So as long as you see these angles, should be fine. Yeah.
Mm-hmm.
Now, one that okay before we never mind, we'll just move on. Let's go to the next bit here. I'm gonna paste that right there. We're gonna focus again on the first quadrant only.
Mm-hmm.
All right, we're gonna focus on the first quadrant only. And now we're gonna look at that middle angle right there. What angle does
Mm-hmm.
that look like?
Well, since it's like in the middle of 45 and, middle of 60 and 30, it would be 45, yeah?
Yeah, this would be 45 degrees, correct, right? Now,
Mm-hmm.
if you look at this, we are now going to actually solve this by doing this, okay? Now you see here that since that's 45 degrees, let's call this length L and this length L. They should be equal because the angles are 45 degrees, right?
Yeah.
That's 45. This is 45 right there, and that's your 90-degree angle. So that
Mm-hmm.
should be the thing, right? So in other words, these two lengths equals y, and in this case, L equals x, right?
Mm-hmm.
And of course, we know that the hypotenuse here is still 1. So let's use the Pythagorean theorem again to determine what L is. Okay, so using the Pythagorean theorem, what do we have here again?
Is the L C
C
squared
squared.
equals A squared plus B squared. He was
Okay,
saying 2.
then let's put the values in. C is 1, right?
1. Mm-hmm.
Then what's A? L, right?
L. Mm-hmm.
L squared plus
L squared.
L squared. So that's gonna give us 1 equal, well, let's put the square there first. So that's 1 equals 2L squared, right?
Mhm.
And then L squared is equal to 1 half.
Mm.
And then finally, we can write this as L is equal to, since we're talking lengths, they have to be what? The positive value only. The square root
Mhm.
of 1 half, right?
Ah. Mhm.
Now, one thing that you've probably learned before is you don't really want to express a fraction. Well, the square root of a fraction. We don't like doing that in math for some
Mhm.
reason. So we're going to have to express
Yeah.
that as square root of 1 over square root of 2, right?
Mhm.
But we also don't like
Mhm.
we also don't like the square root sign in the denominator. We want to get rid of that.
Yeah.
But square root of
Mhm.
1, so I'm just going to write that as 1 over square root of 2 because square root of 1 is 1, right? Since we
Yeah.
don't like that,
So
what do we do?
you times it by square root of 2 over square root of 2 because that's the same thing as 1.
Yes, exactly. Now what do we get here? This leaves us with square root of 2 over square root of 2 times square root of 2 is 2, right?
2.
So that's your
Mhm.
L.
All right.
All right. So what does this mean? Let's go back to our unit circle. Then that means that the length x is equal to what? The length,
2 the negative 2 over 2. I mean,
okay?
no, not over 2. I mean, square root. I'm like, wait, forgot the name. I
Square
was
root
like,
of 2 over 2. Correct, right?
mhm.
Same
Yeah.
thing with the y. This is going to be square root of 2 over 2, right?
Okay. Yeah.
Okay. Now, okay. Now, your turn. Knowing that, fill in this thing with this angle and the values here, this angle and the values here, this angle and the values here. Knowing
That's
that,
a lot of
mhm,
that's a lot of twos.
yes. Uh-huh.
Oh, wait.
Don't
Should I?
forget the
Oh yeah,
signs. Don't forget the
I'll add
signs.
I'll add the negatives later.
All right, all right, all right. Got that.
Yeah. I want to get all the twos down.
Mm-hmm.
Look at all those twos.
I
Whoa.
know, right?
Hold
But
on, I'm just gonna.
this makes the 45-degree angle. This is one of the special angles again. And this makes it easy because it's
Easy
just
to memorize.
it's easy to memorize. Now, later I'll show
Mhm.
you something that would actually help you even memorize this even easier.
Ooh. All
Okay?
right. Please show. That's like what I'm struggling with the most in this because I'm
Mm-hmm.
like, there's so many numbers.
Right. But now you see it's quite easy because all you have to remember is either 1, 0, square root of 3 over 2 and 1 half, or what square root of 2 over 2. They always occur
Mhm.
in those pairs, right?
Mhm.
Okay. How about the angles?
So this one's 45.
Mm-hmm.
45 plus 90.
Mm-hmm.
Um, I'm gonna calculate that real quick. 135.
Mm-hmm.
180. 225. And then 270.
Mm-hmm.
315. Isn't there like the other thing you said from at the first one about like negative thing of
Yeah.
them just kind of yeah.
Yeah. So you just write the negative versions of at least the bottom angles.
Mm.
Because you never go
So
beyond negative 180 anyway, at least in problems, right?
yeah, that makes sense.
Okay. Okay, great. So, all right. So basically that's it. Okay. So
Hmm.
if you look at the unit circle, basically this is how it should actually look like. Oops, I accidentally covered the other one.
Oh
Nah, it's fine. I think you can still get what it is, right?
yes.
Okay. All right. Now, let's kind of summarize this first before we look at certain patterns. What we can do is we can summarize the results and then try to see patterns in order for us to understand it better. And then we also
Mhm.
look for other patterns for us to see certain relationships between the different trigonometric functions. Okay, so
Mhm.
let's take a look at this first. I'm going to make now a table. So summarizing the results. Okay, so basically this is what I'll do. The angle, okay, in degrees. Um, this is the x coordinate for the unit circle, right? And this is
Mhm.
the y coordinate. Okay, I'm just gonna do the 30, 60, and 0. I'll include 0, okay? 0
Mhm.
degrees, 30 degrees, um, 45, 60, and 90. The rest, again, will just follow according to what we just did, right?
All right, because it's kind of like that, just that, but like repeated.
Yeah, exactly. So the x coordinate of the x of 0 degrees is, let's just start with 1, right? And
Mhm.
you'll notice that I'm writing it off to the side because I'll show you the pattern that most most math classes don't teach. The pattern is there, but they don't teach it for some reason. Okay.
Okay.
Now, this means that the y coordinate of 0 is 0, right?
Mhm.
Now, what's the x coordinate of 30 degrees, if you recall? Or we can
I
do, we
mean,
can come back. We
go
can
back.
come back.
Go back.
Go back. Okay.
The negative. I mean, not negative.
Right here.
Square root of 3, 2 over 2.
Square root of 3 over 2, right? Ah,
Mhm.
I'll write that. Okay. Um, and then this is 1/2, right?
Yeah.
And then this means it's the other way around for 60 degrees. This is the 1/2, and this is the square root of 3 over 2, right?
Mhm.
Okay. How about 45? We know that for 45, those two should be equal. They should be.
Well, um, square root of 2 over 2. I was about to say negative again. Oh my gosh.
Okay, that's fine. But okay, hold on. Square root of 2 over 2. And finally, for 90 degrees, it's gonna be 0 and 1 here, right?
Yeah.
Now, here is a pattern. Again, it's right there if you know how to solve for it. The pattern is right there, but it's not normally taught in classes for one reason
Wait.
or another.
Wait a second.
Do you see the pattern?
Kinda.
What is it?
Like, if we're gonna ignore the 0 and 90. I was like a 3, 2, 1, 1, 2, 3.
Actually, we can also not ignore the 0 and 90. We can
Oh.
add to that. Why? Because all of them have over 2, right?
Mhm.
I'm just going to write over, oh, sorry, not negative 2 there. Over 2 and over 2. This one is pretty obvious. That's 0, right?
Mhm.
Okay, but I won't write it as 0 just yet
Mhm.
because once, hold on, 2, 2, 2, 2, and 2 here. I'm going to show you exactly. I'm going to start off with this. This is obvious. This is going to be square root of 3. You can't change that, right?
Mhm.
You can't also change this as square root of 2. But 1 is in fact the square root of 1, isn't it?
Mhm.
What's 0 as a square root?
0.
You see a pattern? You see the pattern yet?
Yeah.
So what is this? This is the square root of what?
4.
Ah, done. That's your pattern.
Whoa.
I know, right?
I, I just saw like the 3, 2, 1 and 1, 2, 3. I was just like, wait a second.
All right. So that means it's the same for the other way, for the y coordinate, but it's just
Just
the
like flip
opposite.
flop.
Yeah, this is square root of 0, square root of 1, square root of 2 here, square root of 3 here, and finally square root of 4 here, right? So
Hmm. Mhm.
this makes a whole lot of sense if you think about it in terms of a square root of something over 2, because it just goes 0, 1, 2, 3, 4.
Mhm.
Pattern is easily seen, right? So This
Yeah.
should help you memorize it, but once you've already memorized it, you should just say 1 square root of 3 over 2 square root of 2 over 2 square root of 1 half and 0. Okay?
Mhm.
All right. So that's the first part. Memorize this, and you'll memorize all the other special angles.
Yay!
Okay. There is one more thing I want to say. I don't think you've learned this just yet, or maybe you have. Have you learned about, I want to ask this. Have you learned about, well, let me just go scroll down first. Have you learned what this is? What is cosine of negative x? What is sine of negative x? And what is tangent of negative x compared equal to?
I don't think so.
Well, if you haven't, now's a perfect opportunity for us to look at this. Okay?
Yay!
Right? Why? Because this can easily be seen on the unit circle. If you just think
Mm.
about it and try to prove it and everything, it kind of later on, you'll probably be learning this later anyway. But
Mhm.
the idea here is once you see the unit circle, it's gonna be so much easier to remember these instead of trying to memorize again which one is which. Okay.
Mhm.
All right. So I'm gonna reintroduce the unit circle here again, and we're gonna look at patterns. This time around, uh, okay. This time around, hold on, stop. There we go. Move, move. Okay. This time around, since you already know the values, let's just write them up, right? And zoom in a bit.
Mhm.
Okay. So also one more, what is the one thing that we've seen here? The x coordinate is the cosine, right? And the y
Yes.
coordinate is the sine. So let's kind of put that here.
Mhm.
So cosine of the angle. I think I know what's happening now. I think I'm kind of accidentally pressing my keyboard with my arm when I write.
Oh.
So that's why it kind of jumps around. All right. So anyway, let's use orange on this one. This is going to be the cosine of the angle.
Mhm.
Okay. This is going to be the sine of the angle. Okay.
Mhm.
Okay. Now,
Ready?
uh, let's go back now here to this. So let's start with, okay, let's start with this. This is gonna be square root of 3 over 2 and 1 half here. And I'll write all those again. So square root of,
Mhm.
sorry, the other way around. So this is 1 half square root of 3 over 2. So this is negative 1 half square root of 3 over 2. This is negative square root of 3 over 2. 1 half. Same thing, negative square root of 3 over 2 is negative 1 half. Negative 1 half here, negative square root of 3 over 2. And the
Mm.
last one, this is square root of 3 over 2, 1 half. And this, negative 1 half. And then 1 half here, negative square root of 3 over 2. Okay, so remember, x is cosine, y is sine, right?
Mhm.
So let's look here. Let's take a look here and let's just write it bit by bit. This will still hold true even if you write the 45-degree angles, but it's not so useful to see. Okay, so we'll look at this one. Now, I'm going to say that this is our cosine theta. Okay,
Okay.
all right. So let's now compare what is cosine of negative theta. My arm. Okay, what's the cosine of negative theta? How would you draw that? Remember, we said we can go negative angles, we go clockwise, right?
Yeah.
Okay,
So it's like me.
yeah. So what's cosine? Oops, I think I may have written this wrong. I'll just rewrite that. Just rewrite it. It should be the other way. It should be square root of 3 over 2 minus 1 half. 1 half square root of 3 over 2 negative. All right?
Mhm.
All right. So with this in mind, let's go back. What's cosine of negative theta?
Um. So since the first is cosine, would it be like the negative 3, 2?
Okay. Now, let's just write it like that over here. Square root of 3 over
Okay.
2, right? But
Yeah.
is it square root of 3 over 2 also cosine theta?
Yeah.
Yeah. Now, this will apply to any angle, but it's most visually seen with the unit circle. So this is also
Mm.
cosine of theta. All right? So
Uh
that's the
huh.
first one. Now let's do the other one. Let's put all the cosines on that side and let's put all the sines here. What is the sine of
All
negative
right.
theta?
It would just be -1.
Okay. Now I want you to focus on this and I'm going to put a bracket. What is 1/2 here
That
in
equals
this case,
the
right?
normal cosine beta.
Not cosine, sine,
Oh.
right?
Oh.
Okay. But remember, you also have this negative sign right there. So this should have a negative sign here.
Okay.
Okay, so cosine of negative theta is the same as cosine theta, but the sine of negative theta is the negative of the sine of theta.
Mhm.
Yeah?
Yeah.
So I'll erase this, just edit that. So in this case, theta. Negative sine of theta. Okay?
Mhm.
All right, so that's the second thing we can do. In fact, we can see a lot of different patterns here. We're just
Yeah.
gonna explore the easier ones, okay? So
Mhm.
negative sine theta, right? Okay, now let's take a look at this. What is the cosine of um 90 plus theta? 90 degrees plus theta. So let's take a look here.
90.
Again, this is the cosine, and then you add theta, you add 90 degrees to it, so it's this angle, right?
Yeah, like B.
So it's okay, so there.
Yeah.
All right, so what is that? Again, we get the value, and we compare that to cosine theta itself,
Um,
or sine
-1
theta.
half. Oh
Mm-hmm.
well, wait. You use the parenthesis maybe.
Yeah, negative 1/2. There we go. And comparing that to the original theta, what is 1/2? So this 1/2 you always compare to this. Oops, I'll use a different
Mhm.
color. So that 1/2 you always compare to this value.
So it would be negative cosine, yeah.
Is it? 1/2 is not cosine in this case.
Wait,
1/2 is the sine, right?
sine. Oh,
Okay,
negative sign.
again, I'll just put it here. Cosine is in x and sine is y, right?
Mhm.
Negative sine theta. Okay, so that's another, yeah, that's another relationship. Okay, let's do the other one here. What is sine of 90 degrees minus plus theta?
That
So
would
again,
be just 3.
square
That's
root of 3 over 2, correct?
mhm.
Which is, compare again to the
The
original theta. That is,
cosine.
okay. Now, we can do a lot of these, like I said earlier, but I think we'll do one more. Okay, we'll do one more. Now, later on, you can use this to prove your other trigonometric identities, but let's do this last one for now.
Mhm.
Um, what is the cosine? So last two, what is the cosine of theta plus 180 degrees?
Ooh,
And also the same here, what is the sine of theta plus 180 degrees?
it'd be this big, right?
Yes, that's right. Uh,
That's like
Okay, let's disregard that. So I'll just do that.
that's 180.
Mm-hmm.
Okay, so cosine would be negative. Oh, it's been actually making a text box. I don't know how
Yeah.
I'm doing that.
I think you can make a text box simply by typing. You press enter and then you type.
I wasn't typing though. I was just like trying to draw.
Ah, all right.
So I don't know what's happening.
Yeah, I haven't figured that one out yet, how that's done, but
Hey,
s-
whoops.
okay.
Uh,
All right.
keep forgetting I have to.
Okay,
Uh,
right, correct. So
which
what's
is
next?
equal to negative. Um, yeah, cosine.
There we go. Correct. And then the last one.
This would be negative 1/2,
Mm-hmm.
which makes negative sine
Okay, great.
0.
Okay, now the reason why I'm putting these up, aside from the fact that you can make a lot of these, is because in math, in physics, this just so we're clear, in physics or the sciences or maybe whatever, if you're taking social sciences, you probably will not deal with these long trigonometric identities, right? You only do
Mm-hmm.
this in math. However, the a lot of the times when you are given problems in trigonometry, you're actually asked to do these. Like, for example, what is the cosine of, given a certain cosine of a certain angle, what's the cosine of that angle of, let's say, okay, let's do it like this. If the cosine of 20 is given, what's the sine of 110 degrees, for example?
Mm.
Okay,
Mm-hmm.
all right. Now, what's important with 110 degrees? Because 110 degrees is basically 20 plus 90. So once you realize that, you can use these things. Okay.
Okay.
All right. Um. Okay. K- You want to see what I mean by that in particular? We'll still use the special angles to make it easier. Okay.
Mm-hmm.
All right. So for example, what is a given? Uh. Okay. Let me just think real quick. Ah. Okay. What is the cosine of let's see, 100 105 degrees. I know 120 degrees.
Sorry. I was just like, hold on, wait,
Okay.
go back.
What's the cosine of 120 degrees? Okay, don't worry. I will go back, but here you go. What you do, what can you
Because I'm
do?
like, wait, isn't that just 60 plus 60?
Yes, it is.
Oh, I was just like, wait, I feel. I don't know, it's not supposed to be decimal, so I'm just like, wait.
So yes, once you realize that it's composed of two special angles, you can actually solve it. You could do 60 plus 60, but there's an easier special angle.
Um, 180 minus 60.
You can do that. There's another possible. So there are three possible things you can do. Actually, there may be more. But the three best
Ooh.
ones are, you said 120 is equal to 60 plus 60, or
Mm-hmm.
180 minus 30. The other one is 90 plus 30, right?
Ooh. Yeah.
Okay. So which one of these is gonna be the most useful?
The 91 or the 181.
Either one of these would be more useful, right?
Yeah.
Okay, so with that in mind, solve for cosine 120 degrees using the unit circle.
Mm-hmm. All right. Finding a fraction. So 90
Uh-huh.
plus 30, and I moved to the image.
Nah, it's fine. Let's just undo it.
No, it's not letting me undo. Oh
Mm.
shoot!
Okay, I'll try to undo it. No, I cannot undo what you've done. No.
Uh, just gonna.
Oh, there we go. Fixed it.
There we go. Just like nothing happened.
Mm-hmm.
Hey, I was holding down on it too long. Okay, so 90 plus 30 is this one,
Uh-huh.
this line, this line.
Uh-huh.
So, oh shoot, it's still weird, but we're just gonna ignore that. Um,
And you
and
all
cosine would
uh-huh.
negative one half.
Okay. Now, that's that's using the unit circle, right?
Mm-hmm.
Okay. So, okay, how about we use what we use this thing that we just learned, this thing, one of these. Cosine of negative theta, cosine of 90 plus theta, or cosine of 180 theta plus 180.
So are we still gonna use the original theta? How did I move this? This is bothering me now.
I'm also trying to figure that out because I could never have done that until you showed me that it is possible. It's the first time I've seen it move. There we go. All right,
Okay, we're just gonna leave it at that and
just
not
leave it.
move it anymore.
All right.
So are we gonna still use the original over here? Yeah.
Mm-hmm. Now, okay, what I want you to use now is one of these. Okay.
Mm-hmm.
Okay, let me zoom out a bit first so you can write and watch. Write and see.
Mm-hmm.
All right.
Yeah. So, so you
So
just want me to rewrite it?
yeah. So what I when you so this is what you can do. Yeah. So rewrite it like that. Cosine of 120 degrees is equal to something, one of these, right? One of these
Ooh.
things.
Mm-hmm.
Which
Okay.
so again, you can use either the second or the third one, right? But your theta is what? 30, right?
Mm-hmm. 30.
Okay. So you write plus 30.
Okay. So I just
Okay.
put plus 30 then,
Yes. Okay. And then
and then I add the
equal
negative.
negative sine theta.
Oh, okay.
You do this part, the negative sine theta. Okay. What's our theta again? What's your theta between these two?
Uh,
Your theta is not 90, your theta is 30, right? So you write here
30.
sine 30. Negative sine of
Okay.
30. Right. All right. And
Hmm.
then from there, you just do the trigonometric identities again. Sine 30 is 1 half. So that's the
Yep.
final answer is negative 1 half, right?
Mm-hmm.
There we go. Done.
There we go.
All right. So, well, you learned something new, I hope.
Yeah. I'm like trying. I think I can memorize this now.
Mm-hmm. So again, either through the unit circle with the way we did it, or memorizing this table with this
Okay.
particular pattern, right?
Mm-hmm.
Okay.
All
So,
right.
you have any questions before we finish for today? Then
No.
no questions. All right. So Ariana,
Yeah.
thank you for coming. I'll see you again next week.
Okay. Bye
All right.
bye.
Bye bye. See ya. Have a good day.
You too.
Done. Okay. So that's the end of the lesson there. So, uh yeah, trigonometry is actually a pretty fun thing if you try to find like patterns on the things you have to memorize. That's actually true for anything you want to learn, whether it's mathematics, physics, or whatever the science is, or whatever subject it is in school, or even if it's something you love to do. The best way to learn how to do it properly is to find those patterns, and yeah, after you find the patterns, you use them to do something else. So, okay. All right, so with that out of the way, so we're done for today then. So before we end, again, I want to remind everyone to subscribe to any of the social media platforms here. And yep, okay, so this week I'm probably gonna be able to do everything that haven't been done so far. Yeah, it's been a very hectic couple of weeks, 3 weeks. Hopefully today, starting today, or maybe starting this week, I can start working on the social media stuff like the shorts, posts, whatever. All right. So with that, thank you again, everyone, for if you watch this and you found this useful. Again, don't forget to like, share, and subscribe to any of the social media platforms. That's it for today. So for that, I bid you all good evening, good day, good morning, good afternoon, wherever you are in the world again, and stay freaky, everyone. Bye bye now.